we're solving quadratic inequalities in one variable. We've already done this, but really we've done it graphically. So now we're going to look at some algebraic solutions, different methods. So we've looked at it, how we can do it graphically and then come up with sets of solutions, but there are different methods. So you just want to be aware of them. So there's 4 different quadratic inequalities listed there: less than, greater than, less than or equal to, greater than or equal to. Okay, so we'll go through these methods. First one is graphically, and we've actually graphed them for you. So this is a review of what we've already done. So it says use the graph to solve each of the following inequalities. Notice how the left side is the same for all of them. So it's the same quadratic. In terms of, so remember, this is in one variable. So that means we're trying to find all the values of x that satisfy these. It's not in 2 variables where we would shade in a region because we couldn't list all the values or couldn't sort of show it in a solution set. So here we're looking for, so this is your function. So if we call this f of x, then this is y equals f of x graphed. When is it equal to 0? You're just looking for your x-intercepts. So x equals -2 and 4. Those are your solutions. The next one, where is it greater than or equal to 0? So that's in this part here. This part here. So it's really where is y greater than or equal to 0? That's always above the x-axis, including the x-axis here because it does have an equal sign. So we do include the 4 and the -2, but it's going to be x less than or equal to -2 or x greater than or equal to 4. You can use a comma or the word or. Okay, next one is just greater than, so it's the same as the last one, but it doesn't include those 2 values. So that's going to be less than -2 or greater than 4. Now, less than or equal to. So that's this part here, including the x-intercepts. So that's going to be between -2 and 4. X is between there. So I kind of write down my boundary values, and then I put my x in between with the correct inequality sign, always opening to the biggest number. And then less than is everything here, but not including those values. Okay, so graphically is an easy way to see a solution. Sometimes if you want exact values, then obviously you have to use quadratic formula or something like that. So you can't just punch it into your calculator per se. But you can certainly do that to sort of check you're looking at the right areas. By graphing, factor where possible. So we've got this number line here. That can be like our x-axis. So we don't really care about the y-axis per se because we're just looking above and below as opposed to left and right. We factor this. We need 2 numbers that multiply to -12 and add to 11. So that's going to be 12 and -1. So that'll be a +3 and a -1x. Okay, so our x-intercepts are -3 and 1/4. Okay, so you don't have to scale it out. If you were to graph this, its leading coefficient is positive. Oops. So it would look something like that. Okay. Where is that graph above the x-axis? So here and here with open circles. So your solution set is going to be x less than -3 or x greater than 1/4. Okay, so we solved that by doing a quick sketch. So I solved by graphing. Okay, next one. Going to factor out a negative. I'm not going to divide yet. I want to actually graph it the way it's shown here. You could divide, and then that would change the direction of your inequality. That's the correct answer. Okay, can we factor this? Two numbers that multiply to negative 30 and add to 7. Oh, that should be 2x squared. So 2x and x. So negative 30. So that means we want to have 10 and negative 3. So plus 5 minus 3. And so our x-intercepts are negative 5 and 3 over 2. It's got a negative leading coefficient. I haven't divided by a negative. So now I'm looking for when this is greater than 0. So I'm looking for this. Again, open circles there. That's just, the red part is just kind of a rough sketch. It's not really correct, proper solution, right? So now I want to be have x values between negative 5 and 3 over 2, and no equal sign on those. So you can see if I had divided by negative 1 here, I would have got 2x squared plus 7x minus 15 less than 0. So then factoring and then graphing that, same x-intercepts. Okay, but this would be opening up, and I'd be looking for where it is less than 0, which is in here between negative 5 and 3 over 2. So you get the same solution. All right, so that's graphically. Oh, a couple more, sorry. This one here, can we factor it? Yeah, it's actually a perfect square trinomial. All right, so we've got x equals 3, multiplicity of 2, so it's U-shaped there. Okay, where is it greater than or equal to 0? Well, everywhere on that graph, right, because it doesn't go back down. So this is x is an element of all real numbers. Every single point there. If it didn't have the equal sign, then it would be everything except 3. Next one, same thing, it's got a negative. Okay, so in terms of this, it's x squared plus 5. X squared plus 5, you can't factor that, right? So it's not going to have any x-intercepts. It's going to be a graph kind of looking, looking down here, actually. Because if you take a look at this, it's opening down, the vertex is 0, negative 5. Okay, so in this case, where is it greater than or equal to 0? Nowhere. So there's no solutions to this. You can state it out in words, you can do null set, you can do empty set. Okay, because there aren't any solutions for that. And I just realized that you did not have those questions on your note sheet. Oh yeah, you did. Sorry. Okay. All right, so now we're going to work backwards, write a quadratic inequality in factored form, and then in simplified form. It has this as a solution. So you might even want to draw a number line. And so we've got negative 3 and 5. And x has to be a solution values between those, right, if we were to graph the solutions set. So we know we've got to have factors of x plus 3 and x minus 5. And if that has to be our solution set, then let's say if we keep that positive, which is basically leaving it like this, then if we want that solution set between negative 3 and 5, we want to be looking below the x-axis. So we've got to be looking for less than 0. It does have equal signs in our inequality solution, so we need the equal sign. Okay? And then in simplified form, so you're just expanding out. Okay. Next one, so x-intercepts of 2 and 6. So our solution graph looks like that. So that's like the arms of a parabola. When we write out our factors, we need to think about, okay, well, when are the arms? If I do this opening down, then it's for everything that's below the x-axis. If I graph it opening up, then it's for everything that's above the x-axis, so greater than 0. No equal sign because there's no equal sign in our solution set. And so then expand it out. Okay. All right. Next one is, this is using test points. So solve that quadratic using roots and test points by completing the following steps. So these are the steps to do it in this method. When you get to calculus, you'll need to do this not just for quadratics, for a lot of them, and you won't have a calculator, so you won't be able to graph it. So you will need to use some kind of method, algebraic method, and this is sort of this close to the one that I like to use. Okay, I kind of combine it with a number line. So in a way, mine is sort of a combination of question 4 and 5 here today. So solve the corresponding equation. So if we have 2x squared minus 11x plus 5 equals 0, we can factor that. So minus 5 minus 1, so x equals 1/2 and positive 5. Plot the roots on a number line, okay? So 1/2 and 5. Choose a test point in each interval, okay? So what are the intervals? Well, these solutions divided into 3 intervals. So what are the intervals is x less than 1/2, one's between 1/2 and 5, and the other one's x greater than 5. Okay, not going to include an equal sign with the inequalities because the original didn't have that. So a test point, so an x value in here. So something less than 1/2 would be maybe x equals 0. Okay. So when you substitute that in, you can put it back into the original, or you can put it back into the factor. The next method is when you put it back into the factor. So let's just put it back into the original, especially when it's 0. That means the value is going to be 5, right? Just the constant term. Okay, is 5 greater than 0? Yes. Right, then another test point between 1/2 and 5, let's do x equals 1. So if we substitute that in, 2 times 1 minus 11 is negative 9, plus 5 is negative 4. I'm not going to show my work in there, I'm just giving the result. And that's, is that greater than 0? No. Then a number greater than 5, let's do 6. So, actually, why don't we do 10? 10 is easier to deal with. So 2 times 10 squared, that's 200, minus 110 is 90, plus 5 is 95, and that's greater than 0, yes. Okay, so we're looking for a solution to this. Where is it greater than 0? So we're looking for this interval and this one. So that's going to be x less than 1/2, x greater than 5. Okay. So it kind of relies on doing a chart, which gets a little bit time consuming. So that's why, as I said, kind of simplify it a little bit when I do it. I have to learn how to learn the right ways for everything. Okay, so next one. This is using sign analysis. So basically you're looking at each of the factors rather than going back into the original. So solve the corresponding equation. So I'm going to factor out a negative. Oops, so that would be minus Okay, so then x minus 3, x plus 2. And so, oh, that's so I'll do the equation, sorry. We don't really care about the negative when we're solving the equation. So those are going to be your two solutions, your two critical values. Plot roots on a number line. Notice how we have a number line down here, so we'll just put them here. So the smallest one is -2, biggest one is 3. And express the original inequality in factored form. All right, so I'm going to include that negative because there isn't 4 sections here, so 1 for each. So negative bracket x minus 3, then bracket x plus 2, and then the overall is multiplied together. You can see it's kind of a double line there because it's the final solution basically. So choose a test value here, so it's kind of like the last one. So in this one, how about -3? Now what we do is we don't go back into the original, especially when you get into higher degree polynomials. That gets time consuming. If you put it back in the factors, it's way easier. So here, if I put in -3 for x, I get, so I'm just going to do this one here. -3 for x, I get -6 in brackets times -1 is +6, so just put a plus. When I put -3 in for the next bracket, I get a negative. Well, a positive times a negative is a negative. Okay. Next test value, oops, x equals 0. Okay, that's an easy one. So negative of 0 minus 3. So again, that's going to be positive. And then 0 plus 2 is positive. So a positive times a positive is positive. And then let's say x equals 4. 4 minus 3 is 1. Make it the opposite sign. 4 plus 2 is 6, positive. And you get a negative answer. Okay, so solutions. So when is this the result here in the last row less than 0? So in this one and this one. Okay, well, take a look at, oops, when that would, oh gosh, sorry. Okay, so then where is it negative? On the number line, it's going to be open circle this way, so x less than -2, and then open circle here to the right, x greater than 3. All right. Okay, so then the last page. Says solve that using case analysis. So this is the last method by completely following the steps. So we're kind of showing you the steps, what case analysis means. So make one side of the inequality 0 and factor it. So that's kind of just makes sense. And factor that. So that's going to be -6 and -1. Oh, that should be a plus, I was going to say. -6 and -1, so that's going to be, yeah. That, so you know your solutions to the corresponding equation are 1/3 and 2. In order for the inequality to be true, the signs of the factors must be, so take a look. If you have two factors multiplied together and your result has to be less than 0, that means one of these has to be positive and one has to be negative. So they must be opposite in sign. So there's two different ways for the signs of the factors to be opposite. For each case, write a pair of inequalities and solve that system. So if in one of the ways that you could get a negative here is if 3x minus 1 is greater than 0 and x minus 2 is less than 0. Okay, so and means when do both of these work? So what you can do here, so we have 1/3 and 2. So solving this, x is greater than 1/3. So that would be there. Solving this, x is less than 2. Open that. And where do they overlap? So they overlap here. Okay, between 1/3 and 2. So x is less than 2, greater than 1/3. Then the other case would be if 3x minus 1 was less than 0 and x minus 2 was greater than 0. So then solving this, these are just the opposite of the last ones. This will be x less than 1/3. This will be x greater than 2. And so less than 1/3 would be here, greater than 2 would be here. Remember, this is and, they both have to, you have to find all the x values that work for both of them, and so nothing overlaps. So there's no solutions from that. So this ends up being your solution set. Okay? So that's what case analysis is. For whatever reason, it's actually less work in a way, but I find taking a look at a number line, looking at test values, finding the sign of the factors, I find that method easier. Okay, so let's do another one though, using case analysis. Make one side of the inequality 0. Okay, factor that. So that's going to be negative 30. Oh, did we do this one already? Yeah, we've done this before. Anyway, whatever. Doesn't matter. So we've got something similar. Okay, so factor that. So you know your possible solutions, if it was an equation, would be -5 and 3/2. Okay, so now for this inequality to be true, so for this to be greater than or equal to 0, the factors, the signs of the factors must be the same, either both positive or both negative. So there's two different ways for that to happen. So if they're both the same, okay, when does that happen when you solve that system? And, okay, so you can do that. So here, this will be x greater than or equal to 3/2. This will be x greater than or equal to -5. Okay, so there. So this is solution to that part. So that's x greater than or equal to 3/2. Next one is when they're both negative. So just the opposite signs, inequality signs. So you can kind of see what's going to happen in this case. 3/2. Okay, so yes, where do they overlap? Okay, that's less than or equal to -5. So overall, it's basically both of these, right? So x less than or equal to -5 or x greater than or equal to 3/2. Okay, so that's the method of case analysis. I pretty much, when I do it, so you have to ask your teacher what method they will expect. Probably on a test, we're not going to be too specific about what method. I kind of do this. I draw a number line and choose a test value, figure out each factor, what overall. I might not even do a chart when you get to calculus. I might just put above it, is it negative, is it positive, is it negative, and then go from there. Okay, so that's it.